All right, hey guys, Mr. Kyle Myers Mathematics, and let's just jump into it. This is number 16. So, find a function f of n, or fn, that identifies the nth term, a sub n, of the following recursively defined sequences as a sub n is equal to f sub n. Okay, so this is the third time now that we're on this particular set of questions, 14, 15, and now 16. They're saying a lot of things, and it might sound a little confusing, but as far as I know, all they really want is just for you to, instead of using a sub n, just use fn instead of a sub n. Because it says find a function fn, but then it says fn is equal to a sub n. So we're actually just finding a sub n. We're finding a explicit formula, either an arithmetic sequence or a geometric sequence or some other kind of sequence that allows us to, say, okay, when n is this, a sub n will be this. So if that's the case, then it shouldn't be too crazy. So let's see here. So n and a sub n. When n is 1, a sub 1, okay, a sub 1 is 1, all right. And then here it's saying a sub n is equal to n plus 1 times a sub n. Okay. Well then if n is 2, if I plug in 1 here, then I'm looking for a sub 2. A sub 2 is equal to, we'll do this off to the side here. A sub 2 is equal to, and then n would be 1. I'm plugging in 1 for n. 1 plus 1 times a sub 1. Okay, well, what is that? That's going to be 2 times a sub 1 is 1. So that's just going to be 2. Okay, simple enough so far. Let's see how it progresses here. So if we're looking for a sub 3, then we're plugging in 2 for n, because it's a sub 2 plus 1. So it's going to be 2 plus 1. So 2n is, I'm plugging in n equals 2, times a sub 2. So that's going to be 3 times a sub 2, and a sub 2 is 2. So that's going to be 6. Okay, and already I'm kind of starting to see a pattern here, but let's do one more just to be sure. If we plug in n equals 3, then that would be a sub 3 plus 1, which is a sub 4. Then this would be 3 plus, we'd be plugging in 3, right? So it'd be 3 plus 1 is 4, so I'm timesing by 4. And then a sub 3, and we said a sub 3 would be 6, and that's going to be 24. So the pattern is that I'm going to times by a bigger number by my previous term every time. I'm going to times, so the pattern here is like the next, so the next one is 24. So the pattern is I times by 2, then by 3, then by 4. And actually there's an operation that does this, and it's called a factorial. So all I have to do now is just say, okay, well, let's just use a factorial and then see if we need to adjust it. In factorial. Okay, so a sub 1 is 1. 1 factorial is 1. Okay, good so far. 2. F of 2, as in a sub 2, well, that would be 2 factorial, which is 2. Okay, still good. F of 3 would be 3 factorial. 3 factorial is 3 times 2 times 1, which is 6. So it looks like we're actually good to go here. This would just be n factorial. Okay, and so part of like why sometimes if you're thinking like, oh, I'm kind of stuck on this, and like, how did you make that look so easy? Part of it is just I know like certain patterns turn into certain things, and you just have to add them one at a time. Like I have a bunch of them just because I've done this for so many years. But all you need to do is just add one pattern recognition at a time, and eventually you'll get there. If you are adding, or if you're timesing by bigger and bigger numbers, then that's a factorial. So lock that one away. Now you have one more added to your repertoire, so to speak. So hopefully that's helpful, and that was the answer to that, and that's how we got that answer. Yeah, check out other videos that are going to be in this series, and also go ahead and check out my website. I have a free thing on there called the 5 math mistakes everyone makes and how to avoid them. It's a free PDF I have on there. You can download it for free. And yeah, catch you in the next video. Blessings, y'all.